Let's look at some equations involving exponents, and by that I mean exponential equations where the variable is in the exponent. First kind we're going to look at is a type 1 problem in which both sides can be expressed with the same base. This takes advantage of this principle. If a is raised to a power and that is equal to a raised to a different power, then those exponents had better be equal. B doesn't need to be just a single number or it can be a whole entire expression like 2x plus 3. And so can C, but those two had better be equal. Here's a simple problem involving that principle. I have 1 over 9 raised to the x power equals 729. Now 1 over 9 and 729 can both be expressed as a power of 9. 1 over 9 is the same as 9 to the negative first. 729 is equal to 9 to the third. That means that I can peel off these exponents and set them equal. Now, when you have a power raised to a power, you're going to multiply the exponents. That means that negative x equals 3, which means that x is equal to negative 3. And if we try that answer back in the original problem, 1/9 raised to the negative third power, that would be the same as 9 over 1 raised to the third power, which is 729. X equals negative 3 is the solution. It's what x could be. Let's look at another one. In this problem, we have 2 raised to a power. 2 raised to the x power is the same as 8 raised to the x plus 2 power. Now, both of these sides are related to the base 2. 2 is raised to a power, so I'm going to leave that side alone. 8 is the same as 2 to the third. And 8 is raised to the x plus 2 power. Well, again, if you have a power raised to a power, you're going to multiply the exponents. So that means I have 2 raised to the x power is equal to 2 raised to the 3x plus 6. Those two bases are the same, just like those two bases are the same. So I'm going to pop off the exponents and set them equal. X equals 3x plus 6. I'm going to take the x's all over to this side, so negative 2x equals 6. And then dividing this side by negative 2 and that side by negative 2, I get x is equal to negative 3. One more example. I have 1 over 25. That's a base. And the exponent on that is x minus 3. On the other side, I have 5 raised to the x minus 3. Well, both of these bases are related to the base 5. I can write this as 5 to the negative first power. 5 to the negative second power, and that is raised to the x minus 3 equals 5 raised to the x minus 3. Multiplying the exponents, negative 2x plus 6 equals x minus 3. And I've popped off the exponents at the same time. I did the multiplication on this side and I just dropped the exponents. So let's finish solving this. I have more x's over here, so I'm going to add 2x to both sides. So I end up with 3x on that side. And then I'm going to move this 3 over to this side. So I'm going to add 3 to both sides. So I get 9 equals 3x. So that means that 3 ought to be equal to an x. Well, let's see if that's true. That means that 1/25 raised to the 3 take away 3 is 1/25 to the 0th power. Likewise, 5 raised to the 3 minus 3 power would be 5 to the 0th power. So this to the 0th, anything to the 0th power is 1, And 1 is equal to 1. So 3 can be equal to an x.